So let's jump to the seat whose name is Fun with the Vehicle Dynamics. Please do not get stressed out while seeing these many numbers. I'm going to explain each and everything. All this number that you see is very easy because we have already done the hard work while driving. The speed of the vehicle as a function of time t, distance covered by the vehicle as a function of time t, and also we derived what is the constant a and b, which I have written here. But that time we have not defined the v infinity. But let me explain you what I mean by the v infinity. So let's say we are in the car and then I just press the pedal. What will happen? Car will start accelerating from 0 to 5 kmph, 10 kmph, and then after what we experience, the vehicle speed become constant. What is that constant speed? That constant speed is defined by here v infinity, which is equal to root over b by a. How we will get this? Come to here and just put time is equal to infinity. What will happen? E to the power infinity will become infinity, and then finally 2 by infinity will become 0, and then we will be left with the only value, which is root over b by a, which I have written here. Now let's proceed. So in this Excel sheet there is only two input parameter, which is slope of the road and the motor torque. So let's put slope of the road 0 and then motor torque. Here I am just defining 10 Newton meter. So this is only two input parameter you have to play with in this sheet. The next area here I am calculating the constant a and b. So I have just converted gradient, which is here in the degree, in just a radian. And then finally I wrote the formula for wheel torque. How we can get wheel torque from the motor torque? We have to just multiply by the gear ratio and the gear efficiency, and then we will get the wheel torque. Now let's calculate the a. What is a? Rho into cd into frontal area divided by the mass of the vehicle here. So I got all the value from the vehicle input set, and then I calculated the value of a. Now let's calculate the value of b. What is the value of b? Which is the torque of the wheel divided by radius of the wheel multiply the vehicle mass minus g multiplied by the sine theta plus rolling resistance multiplied by the cos theta, which I am calculating here. The next, just for ease of referring the formula, I have calculated square root of b by a, because I see here square root of b by a, just to make my Excel formula very neat and clean. That's what I have calculated here. The next, I have calculated the square root of a multiplied by b, which is here. So now we can calculate v infinity, which is nothing but root over b by a, which I have just calculated from these two values. And then what our per kilometer, which I have calculated here, which is solely depends upon the motor torque. Now let's see what is the vehicle velocity when we go from, let's say, time 0 to 5 second, 10 second, 25 second, and up to the infinite second, which in this context the infinite second will be around 3000 second. After that the velocity will see it's almost constant. So let's start from here. So here I have calculated the speed of the vehicle using this formula in meter per second. In the next I just converted into the kmph by multiplying 3.6. Then if we know the vehicle speed, then we can calculate back the motor speed, and that's what I have calculated here. In RPM I have calculated, and then we can calculate the motor power. How we can calculate the motor power? We know the RPM, we know the torque, we can just multiply and then we can calculate the motor power. Just here I have calculated motor power in kilowatt. The next, I have calculated the distance. How we have calculated the distance? Using this formula, which is in the meter, and then just I convert it into the kilometer, and then just I drag this formula till here, which is till 3000 second. In almost all case, this will be the infinity time. Now you will be wondering, what is this 2 rows? So here I have kept just for experimentation purpose. For an example, here you want to calculate a vehicular speed at 65 seconds. What is there? So 26.3 kmph. So this 2 row you can use it for your own experimentation purpose. You can play with this seat, this value here, without touching this here, because I'm using this table to plot all this graph. Now coming to the visual representation of it here, the speed which is in kmph versus time. So I have taken the value from here, speed of the vehicle from this column and the time from this column, and I just draw this curve. So as you can see, after some times the vehicle speed become almost constant. And what is that constant value? 59.8 kmph, which is almost 60 kmph. Now the next, I have drawn the graph between distance, which is in kilometer, versus time, and as you can see, it will keep on increasing. And the next, I have drawn the graph of motor power versus time. As you can see, the motor power increases and it becomes constant. Why? Because torque is anyway constant, and after some time vehicle speed is going to be constant, which means that the motor RPM is going to be constant, and hence the power will be constant. Now you can play with this number and then see what graph that you are getting. Let's say I'm just increasing the motor torque to the 50 Newton meter. So V infinity, I reach to 188 kmph. And then let's put the slope of the vehicle, which is 6 degree. So V infinity, I'm just getting 70.4 kmph. You can play with this seat and see you in the next set of discussion.